Hey everybody, John Wagnon here with Dev Central again, and we have the honor and the privilege of being joined today by three of the great minds in the world, not just in network security, but just in general. So first, hailing from the East Coast, we have Brian McHenry again. So Brian, thanks for joining us.
Hey, glad to be here as always.
Fantastic. Thanks for being here. And then way out west, an entire time zone west of where I am, David Holmes, the man, the myth, the legend. So David, thanks for being here.
I love hanging out with you guys. Love it.
Man.
Thanks for having me.
Yeah, who doesn't? Who doesn't? And then the man where it all started, where Dev Central all got its, the origins of Dev Central began with this man named Jason Romm. So Jason, thanks for being here.
You are welcome. However, that was a good 5 years before me. But,
whoa.
If you want to heap the praise on me, I'll take it.
Yeah. Most of the people that are watching this did not realize that I just lied. Now they do. Thanks, Jason. Fantastic. All right, man. All right. Well, hey, man, great to see you guys again. We've already had one video about just talking about firewalls in general. February is Security Month here on Dev Central. And so we wanted to continue this discussion about our Advanced Firewall Manager, the AFM. And one of the interesting thoughts to start this chat about is that the big IP, the F5, big IP device is a default deny device. So it's inherently it kind of does some of what a firewall would do anyway. So some may question the motivation or the logic behind why did F5 decide to build a network firewall in the beginning. And so, Jason, you mentioned that you've been around for a while, so we figured that maybe you would have a couple of thoughts on some of the motivation, some of the thought behind why an AFM.
Well, I'm going to have my press secretary, Mr. David Holmes, clarify and flat out deny a lot of my statements here in a minute. But I will say that around the time the wheel started turning here at F5, there were a lot of cases of, to quote Brian's, organic DOS scenarios out in the wild where the application delivery layer in customers and providers' infrastructures was completely fine and ready to handle traffic, but the firewall layer in front of the application delivery infrastructure would just absolutely tip over because it could not handle the traffic. And so, the wheels started turning there. It's like, well, to your point, John, it is a default deny box. We do the basic functionality of what firewall does, minus some features that we had to develop in there. But, that's my story. So, David.
Let me fill in some of the gaps there. It's actually a fascinating story. In a weird way, the father of AFM is Julian Assange. Every time you see that guy and his bleach blonde hair, you should think AFM, because what happened was, if you guys remember back when Bradley Manning sent Julian Assange the 250,000 diplomatic cables and he was going to release them on WikiLeaks. And WikiLeaks at the time was being hosted on just some little hosting company somewhere. The famed Patriot hacker, the Jester, attacked WikiLeaks and took it offline. So Julian Assange moves it into Amazon, and then Sarah Palin and Joe Lieberman go and visit Amazon. And the word is that they had a word with them and said, "Could you please drop WikiLeaks as a customer? We don't want this stuff getting out." And they also convinced I think the credit card companies to drop them as a customer as well from taking donations. And then when Anonymous found out about all this, they started attacking everybody who was remotely associated with any of the story. Some of those were F5 customers. And in those particular cases, they were using, Anonymous at the time was using the low orbit ion cannon. If you ever saw the version of it from those days, it had the UDP flood, an HTTP flood, and a TCP flood. And one particular customer, the TCP floods knocked their traditional firewalls offline, and so they just routed around them, sent all the traffic right into the big IPs, and the big IP being a default deny device with SYN cookies built in, just handled everything fine. And so the real birth of the firewall came not at that moment, but later, when after the attack was over, the security team said, okay, you got to turn the firewalls back on. And the application guys were like, everything's cool, man. The F5 is running just fine. It's throwing back all the TCP attacks. Let's just leave it as it is. And the security guys are like, we can't do that because we wouldn't be PCI compliant, and we'll have to put, our payments are going to go up. So there was a tension there, and in that tension, like nature abhors a vacuum and creates energy. We're like, you know what? Why don't we certify the firewall? Why don't we certify ourselves as a firewall? So that was the very beginning of it, and then we started tacking on more and more. If you think about it, DDoS is the driving force in the very beginning behind AFM. As far as I know, it's the only firewall that was built from the beginning to handle distributed denial of service. So does that fill in more of the picture for you, Jason and John?
Absolutely.
That is a much more colorful version of that story than I ever told.
Yeah. Wow. I learned a lot right there, personally. I had no idea I would be saying thank you to Julian Assange one day. Wow, that's crazy. So, but who knows? Hey, the world's a strange place, and strange things happen and lead to other crazy things. So here we are with this AFM and this really highly sophisticated piece of equipment that can do lots of really cool stuff. And so, Brian, I wanted to give you a chance. I know there's a lot of things that this thing can do. But anyway, I wanted to give you a chance to kind of highlight a couple of the things that it does really well that maybe people may not know about.
Yeah, so we talk about the that perimeter of the data center that still needs a measure of protection, right? Even though the perimeter that has been prematurely declared dead a number of times, we want to consider that inbound data flow at the edge of our data center. What can we do to provide better security there? And David and Jason kind of covered some of that volumetric aspect of AFM, right? AFM is really good at lots of connections, lots of concurrency, lots of connections set up and tear down. These types of distributed DOS attacks, whether it's the low orbit ion cannon or its successor type of DOS tools, right? So AFM is really good at that, and it's what's most well known for. But there's some other inbound data flows that we kind of forget about when we talk about AFM, and one of those is DNS, right? So whether your DNS is hosted with a provider or your DNS is hosted on your premises, even when it's hosted with a provider, often you've got the master server sit in your data center, and those provider DNS servers are just slaves to your master DNS. You need to secure that connection. In many cases, firewall ACLs are not good enough in this case because we're talking about UDP traffic flows, so it's very, very easy to spoof traffic in to those master servers, even though there are some DNS mechanisms. So one of the really hard things about securing DNS is, one, it's largely UDP based, right? So UDP means source IP address means nothing. The other thing is that while I may not be able to fill your pipe with DNS requests, because usually relatively small, if we're sticking to A records and other more common types of DNS requests, I can take a perfectly well formatted DNS request, for www.f5.com or devcentral.f5.com, and I can hammer that. It doesn't take a lot of attacker resources to just generate a massive amount of DNS requests. However, DNS servers aren't really good at serving up full responses as a rule, right? So for a while, F5 has been load balancing DNS servers, right? GTM is really good at this in an inline topology, but there are some other aspects there, right? DNS Express. So if you add the GTM license to AFM, you get a full suite of, and really what I would call the only true application-sensitive, application-aware DNS firewall in the market. So you get with AFM, you get full DNS protocol validation. You can do query type filters, so you can make sure you're not even bothering to answer any of those TXT records. With a DNS Express zone transfer via the GTM license, you can also make sure that no NX domain requests get responded to or answered. An NX domain request, I remember the first time I saw it, it was written all in caps, NX domain, right? And I was like, what kind of I've never seen this DNS record before. What is this? And I went looking around for it, and I couldn't find it. And then I realized that this is just some nerd speak for non-existent domain, right? It's not an actual DNS record type. And it's very confusing because we like to write things very official looking, all caps, NX domain. So for those of you out there that are as naive as I once was, an NX domain request is not an actual type of request. It's just a shorthand for a non-existent record that doesn't exist in your zone. But too many of those, and you get overwhelmed. Your DNS server infrastructure can get overwhelmed. So DNS Express, combined with the protocol filters that are built into AFM, as well as the UDP DOS vector handling that is all in the hardware of a big IP or just in the software stack that's in a virtual big IP with AFM. All those things combined together give you a really robust DNS firewall, even if I'm just seeing lots of legitimate requests. So really recommend you take a long, hard look at that, even if you think you're safe because all your DNS is hosted by someone else, and I've just got the master servers tucked away safely in my data center.
All right, thanks, Brian. John, I think, is having a little bit of audio trouble. So, David, you released not a couple weeks ago or maybe a month ago your top 10 hardcore security features in version 12, and you want to talk a little bit about the ones that are maybe specific to AFM.
Sure, absolutely. It's become a little bit of a tradition. I remember when I did the first top 10 for 11.5 or whatever, and I thought it'd be so much fun and stuff, and it was. But it's a ton of work to go through. There's like 60 or 70% of our features are security related now, and I got to go into each one and figure out what it does and then rank them. So in this particular version, 4 of my top 10 are AFM related, and just to go over a couple of them, one of them is in 11.6 we introduced this cool feature that sort of extends the perimeter around the user, and you can actually you can write an ACL where you say the source, instead of giving an IP address, you say the source is John Wagnon, right? And then you can put a block in there, make sure John can't do anything, or make sure he can only log into the mail server between 8 and 9 instead of doing an IP address. Isn't that cool? So that was in 11.6. In version 12, we added the ability for you to specify a fully qualified domain name, an FQDN, in either the source or the destination. And you're thinking, wait a minute, if I did that, won't that result in a DNS query like every time the policy gets accessed? No, of course we cache it. We cache it per the TTL. And let's say we have the IP address that we resolved, and the DNS server goes down. These things do happen. We'll still keep using the IP address that we saw there, just to make sure there's no latency problems. And then there's another one where you can now manage all of your idle timeouts in the same policy in one place. And you might be like, why would you want to do that? Why wouldn't you just want, I'm going to manage the timeout for FTP at the FTP virtual server? No, it's because if you have like a firewall administrator, let him do it or let her do it, and they can just manage all of just the timer policies without having to go to each specific application. Or maybe you have 10 FTP applications or something. They just want to apply a single policy for timeouts. I don't know. I love timeouts. I'm a security person. And then one of the last ones is automation. So they're trying to build a ton of infrastructure automation into the firewall now. And so this one is sub-second if you have like an IP reputation database. Think about how cool it would be if there's a feed coming in and it just automatically programs into the firewall, ignore that IP address, for the next 2 hours. Or how cool would it be to have all these third-party threat intelligence databases basically updating your firewall for you? That's pretty cool stuff. I think that's the wave of the future, because nobody's going to be able to. I've seen customers trying to mail each other like, here's a list of the IP addresses that have been attacking me for the last week, and by the time the email gets to that person, that list is out of date, or they don't trust the list because they think some of them might be the legitimate customers.
So I actually know customers that subscribe to multiple different IP address feeds, and they aggregate diff and then develop their own blacklist, right? So IP address X appears on feed 1 and feed 2, but not feed 3, it goes into a gray list. If it appears on only one feed, then it's put into a white list and it's considered a false positive. But if it appears on all 3, it goes into a definitive blacklist. So they use multiple feeds to kind of vet it and reduce false positives and give themselves a better quality of blacklisting. So, and that's all homespun kind of stuff that they're doing. And I think that you're absolutely right, because I had one customer refer to it as IP address whack-a-mole. It's just not sustainable from a manual perspective, and so I think this is one area where we're getting out in front of some of the biggest problems, and I think IPv6 as it grows is going to be an area where nobody wants to start grooming new ACLs around IPv6 if they can automate it.
So David, you were talking about timers, and so I know from the security guys' perspective, controlling those all in one place, awesome. I know just from my experience working for an enterprise customer at one point, how nightmarish that is for the network team. So you've got your security team, you got your network team, then you have all your application teams, and nobody talks to each other. And so I'm very thankful in the product. There's the flexibility between being able to set that global context, but also having the flexibility of having the unique context per application for the environments to where nobody talks. But given the whole political discussion, which one takes precedence? Like, if you do you know, like with AFM, can it be like a lockdown if the policy is in you're setting a global timer, then it takes precedence over the individual setting?
In general, I believe the answer is yes. AFM stuff is usually handled first before virtual server settings. So I think if you do end up building a timer policy and applying it, it would sort of not overwrite. It would be processed before your virtual server timeouts.
Right. Okay. Cool. Good to know.
Yep.
All right. So, anything else you guys would like to share? Like
I do have two things.
Okay, go ahead.
One of them is my favorite AFM feature is the automatics. They call it automatic sweep and flow. It's like an engineering term, but basically it means if AFM detects like a flood of, say, UDP packets coming in. So let's say you're legitimately processing some UDP like DNS or something, and it gets hit with like a massive spike in UDP traffic. It recognizes this is a massive spike, and it'll start rate limiting, or it'll start throwing stuff away. And you're thinking, well, but that's the same as denial of service, right? I've shut down the processing, but actually AFM will still continue to process up to 8 different subtypes of what it thinks is clean traffic, even during this basically flood prevention. Does that make sense? So let's say you get hit with just a ton of UDP garbage. AFM can still be sitting there picking out what it thinks are legitimate DNS requests and sending those through. So I think that's a super cool feature, and you don't have to do anything, right? It automatically detected the spike. It automatically, started dropping those packets and letting the good stuff through. I think that's super cool, and that's just the way it should work. Yeah. So that's one of my favorites. And then going back to what you were talking about, Brian.
Before you move on, is there a demo of that? Do we have a demo of that?
Would you like me to DOS you right now?
Not personally, no. But I mean, do we have like a canned demo of that we could record and share out to the community sometime?
I'll check and I'll get it to you if we can.
Okay, that'd be great.
And then Brian, I thought maybe if you knew more about, could you go a little bit deeper into the NX domain, because NX domain, besides just being like an error message, it also can be like a code word for a whole suite of attacks where people are trying to overload your DNS server by querying for stuff that doesn't exist.
Yeah.
Mitigation there.
Yeah, it's kind of it's kind of related to the cache poisoning types of attacks we've seen too, right? I mean, is if I can, cache poisoning is like I'm gonna populate your cache with stuff that shouldn't exist there, or with different values than should be there, right? And this is kind of related to it in my mind, right? Is you can flood, if you have a cache out front, and you get a bunch of NX domain requests for stuff that doesn't exist in your domain, right? Garbage.f5.com, which I don't think we have registered. So somebody asks for that a bunch of times, and you have some sort of caching mechanism in your DNS server. You can cache that request, and now it's in your cache as something that was requested, right? And because a lot of DNS servers just really aren't that smart. Bind is frankly is kind of a brute force tool for a very simple protocol, and that's where where I'd say maybe to extend the thinking about DNS firewalling is to look at BIG-IP as not just a DNS firewall, but a DNS delivery mechanism, right? We're doing everything for DNS with AFM and GTM as an inline proxy-based service that we've always done for HTTP and SSL over on the LTM side of the house, right? So think of AFM and GTM as like this powerful 1-2 punch of DNS delivery services that relate to security, relate to performance, and NX domain is really insidious because it can be used to very easily flood your servers, and if you've got nothing in between as a logical filter for those kinds of requests, or nothing with enough performance to keep up with that, then you're basically just hoping that you have enough capacity in your environment. And nobody knows about capacity better than F5 in terms of high availability distributing traffic.
So real quick before we wrap up, where would you draw the line between where AFM ends and ASM starts, or is there overlap? Is there complementary, competing pieces within those two realms?
So there's definitely overlap, right? So they're both built on TMOS, first of all, right? They're both powered by the wonder of TMOS, which includes in both instances, whether you're talking about ASM or AFM, so the WAF or the data center firewall, includes the mightily powered TCP Express stack, which is the beating heart of TMOS in my opinion, and is what makes the DOS handling capabilities in AFM so robust. And then the SSL stack. So there is some overlap there. And then in AFM, there are also HTTP protocol enforcement that's available as well, right? So it's not full-blown application security, web app firewall type thing. So you're not getting signatures, but and advanced bot detection and all those kinds of fancy things. But you are getting, make sure this HTTP request is well formatted. If it declares HTTP version 1.1, there should be a host header there, right? These are some simple things we can do to get rid of bad traffic. So there is a little bit of overlap, but when you get into more advanced attacks, you do need to add on ASM to provide yourself an advanced level of capability and security. And that reminds me, that little bit of overlap area reminds me of a point I wanted to make on our Hangout today, is that a lot of people look at AFM, they think, oh, this is the data center firewall, this is my part of my DOS mitigation solution. I've got these handful of protocol filters for DNS and FTP and HTTP and so on, but they kind of forget that every BIG-IP comes with SSL offload. The SSL offload, that means even Advanced Firewall Manager comes with SSL offload. So if you want to start looking at decrypted gap solutions in your network on the inbound traffic, you want to create an area where other devices may need to or want to inspect previously encrypted traffic. That includes not just security devices, but performance management and monitoring solutions, user experience monitoring solutions that may need a copy of the traffic. As everything becomes SSL, we don't normally associate firewalls with handling high-scale SSL traffic. And AFM, just like every other big IP, handles tons of SSL and might be just the right place in your network to provide that SSL termination point, provide visibility for other services in your network.
Okay, it sounds like John's still having some audio problems, so I'll wrap up here. That's an excellent point, Brian. And guys, thanks for joining us again and diving into AFM. I will tease, after Security Month, we're focusing on AFM this week. We've got a few other topics coming in the weeks following, where we're going to dive into OWASP and Silverline and some of our partner solutions this month. And then starting in March, we're actually going to have we haven't determined exactly, but an 8 to 10 part series diving into the specifics of AFM and configuration and advanced solutions, and we might even break out some iRules and some orchestration stuff as well. So I look forward to that. Guys, thanks for joining us today. And John, sorry about your audio, man. You just got left out in this second half of this call. So, but we've enjoyed looking at you at least.
Oh, speak for yourself.
All right, guys, appreciate it. Thanks a lot.
See you, Jason.
See ya.
See you, Brian.